equivalent weight is completed, right? Next, concentration terms. Concentration terms. Actually, this is first part of solutions. Amen. First part of solutions. Second year solutions chapter, first part, concentration terms. Okay, again, all these topics will come in solutions also. Right. What are concentration terms? Concentration term is used to express the amount of solute. Amount of solute in solution. Concentration term used to express amount of solute in solution. See, for example, you are holding some 10 gram salt. You are saying that is 10 gram, but after dissolving in water you cannot say 10 gram salt is present in solution. You have to say in terms of concentration terms. Okay, 10 molar, like 10 molar. You should not use weight. Before dissolving we can say 10 gram salt is present in my hand, but after dissolving in water you cannot say 10 gram. Special terms are used to express the weight of solute in solution. After dissolving in water you cannot use 10 gram salt is present in it, but we will do numericals based on the data only. But main use of concentration term is used to express amount of solute in solution, right? Okay, these are the concentration terms, important concentration terms. Weight percent also represented as small w by capital W percent. And volume percent, V by V. Actually we do not discuss about volume percent, just write volume percent. Third one is important, weight volume. We will discuss about this. Weight volume percent, W by V percent. See, in some numericals we will get notations like 10% weight, 10% weight by volume. Okay, we should understand what is the meaning of weight percent, volume percent. Okay, next, fourth one, molarity is coming. Molarity. Normality, molality, and mole fraction. See, in solutions again we do not discuss mole fraction. Okay, this is a basic topic, right? We will take formulas, concepts directly in second year solution chapter. And ppm also there, parts per million. This is also one concentration term. Weight percent, volume percent, weight volume, molarity, normality, molality, mole fraction, and the ppm. Online students, hello. Ketura, Pragnika. First one heading, weight percent. Weight percent, we do not discuss any definitions. So we will go with the direct notation useful for the numerical part. Okay. The first one, weight percent. Shall we go to next concept? Online students, shall I clear this? First one, weight percent. See, directly I will give the notation because basic formulas, questions would come on the basic formulas. Write directly notation. Notation is important for us. In regular class we will discuss everything, but here no need notation. See, 10% W by W, NaOH solution. Okay, or 10% aqueous. Actually NaOH solution means aqueous solution only. Aqueous NaOH solution by weight. We should write the data related to this notation. Offline students, how many of you say the meaning for this notation? Pritika.
Solution is present in 100.
Say again loudly.
10 grams of NaOH solution is present in 100.
Grams of NaOH solution. Solution is in solution.
Solute is in solution.
Online students, you tell me. Okay. See, this number always, what is the number here? 10, 20, 30. The number is there. That number represent weight of solute. Weight of solute. Okay. Weight of solute. 10 grams of NaOH. That is common. 10 grams of NaOH, 20 grams of NaOH. This percentage value is there, 10%, 20%. That value, don't say again percentage, 10 grams. Some students will say 10% NaOH, that is also wrong. 10 grams NaOH. 10 grams NaOH present in 100 grams of the solution. 100 grams. So meaning 10 grams of NaOH is present in 100 grams of solution. 100 grams of solution. See, this 100 grams is common irrespective of this number 10, 20%, 30%, 40%. Always the notation meaning ends with 100 grams of solution. You can take 40%, 50%, 80%, 90%, but the sentence always ends with 100 grams of the solution. This is common. Yashvi, are you there? Pragnika? Yashvi and Pragnika. Santoshini? Let us write now useful information. Expand the data. Weight of NaOH. Weight of NaOH is equal to, tell me, what is the weight of NaOH? 10 grams. Weight of solution. Wasabi? Solution weight, 100 grams. Now, weight of solvent. Weight of solvent. 100 minus 10. 100 minus 10. Next page. Weight of solvent. Weight of solvent is equal to 100 minus 10. That is equal to 90 grams. Where we use this notation in molality calculations in first year stoichiometry numericals, and in the second year solutions chapter also. In molality, we have questions based on weight percent notation. Okay, we need solvent weight. Clear? You write a meaning for this notation. Another example for you. Write fastly. 30% W by W Na2CO3 solution. Write fastly. Directly, okay, don't write any sentence, just weight of Na2CO3, weight of solution, weight of solvent. Online students. Okay. Now, weight of Na2CO3, 30 grams. Solution is always constant, 100 grams. Solvent weight 70. 100 minus 30, 70. So first notation is over. Okay, weight percent notation. Second, volume. We won't discuss volume. Write directly weight volume percent. Third one, weight volume percent. Here also I am directly giving notation, weight volume percent notation. See, 20% W by V NaOH solution. Meaning for this, 20% W by V NaOH solution. Madhiha, can you try?
20 grams of NaOH solute present in 100 ml.
100 ml. One is weight, one is volume. Okay. Write directly. Weight of NaOH is equal to 20 grams. Volume of solution is 100 ml. Enough. Close. In molarity numericals, we will use this molarity. Okay, what is the molarity of 10% W by V NaOH solution? Like that. Okay. So weight percent, weight volume percent is our next key betting molarity. Molarity. Vaishnavi, doubt ఉందా ఏమన్నా? ఓకేనా? Molarity. In solutions chapter, it will be very easy if we do some questions here. Molarity definition, simple definition. Definition is important. Correct definition of molarity? Any idea? Online students. Pragnika, are you there? Yashvi, can you say the definition? Akshara? Anybody? Online students? Make it fast. No. Definition. Definition is important, not the formula. Definition. If definitions are important, then I'll give the definitions. Kirti, we know already solutions. Number of moles of solute present in 1 liter solution. Definition is important. Once look at this, all of you. Let us take 1 liter solution. This is 1 liter solution. Okay. This is 1 mole. This is 1 mole. This is another mole. All these represent moles. These spheres represent moles. Means inside this sphere, some 6 into 10 power 23 particles are. All these are particles. How many particles are present inside the sphere? 6 into 10 power 23. Inside the sphere, how many particles are present? 6 into 10 power 23 means 1 mole only, na? So this is 1 mole, this is 1 mole, this is 1 mole, this is 1 mole. So number of moles of solute present in 1 liter solution is called as molarity. Number of moles of solute present in 1 liter solution is called as molarity. Because this definition is useful in some numericals. Okay, based on the definition, we can write first formula. What is the definition? Number of moles present in 1 liter solution. 1 liter solution, not solvent, remember. Where we get solvent? Where we get solvent? In the definition. In which concentration term we will get solvent? Molality. Molality. See, first formula. Molarity is equal to number of moles by volume in liter. Number of moles present in 1 liter solution. Number of moles by volume in liter. From this, number of moles is equal to molarity into volume in liter. See, send V this side, then we will get M into V. Okay. This is number of moles and number of millimoles. Number of millimoles. When we express volume in ml, then we will get a number of millimoles. In number of moles, volume is expressed in liter. In number of millimoles or millimoles, volume is expressed in ml. If you want to calculate number of millimoles, then take volume in ml. This is first formula. Second formula, molarity is equal to expand number of moles. Number of moles, weight by gram molecular weight into 1000 by volume in ml. Akshara, Pranavi, Juhi, Ketra, Gayatri, Pragnika, Sanjana, follow up nama? Sanjana, Misbah. Third formula. Oh, sorry. Molarity is equal to weight percent into 10 into density by gram molecular weight. Sometimes numericals will come based on the formulas. Okay, molarity and density relation. See, sometimes d is replaced by specific gravity, density or specific gravity. Here d means not specific gravity, don't confuse with that, otherwise you will confuse like that. In place of density we can take a specific gravity, that is my meaning, density by specific gravity. In place of d you can put specific gravity also. Instead of writing formula again, write like this. If specific gravity data is given, then also we can use, we need weight percent and density. Okay, in solution we can skip first part. Okay, we can start from the Raoult's law onwards, vapor pressure concept onwards, because here we are doing right. Next, dilution principle. Let us consider one solution is having 10 moles. 10 moles. 10 moles. Adding water or any solvent, some XML water. We are adding XML water. Addition of solvent or water is called as dilution. Okay. You tell me, after adding or upon adding, is there any change in the number of moles? See, inside beaker how many moles are present? 10 moles are present. After adding water, 10 moles will become 20 or same or less than 10. 10 moles will become 10 mole only. Imagine a bucket having 10 red color balls. Pour some water. Is there any change in the number of balls? Number of moles are constant. Upon dilution, what is constant? Number of moles is constant. But volume increases. Volume increases, right? What is the formula? Number of moles is equal to molarity into volume, right? This is given. Okay, under first formula. But N is constant or not? N is constant. Number of moles are not changing. So constant. N is equal to constant into M into V. See, if we have a relation like this, can we write like this? M1 V1 is equal to M2 V2. This is dilution principle. So when we use this formula, when you observe amount of water is added, solvent is added or diluted to, then use this formula. M1 V1 is equal to M2 V2 is called as dilution principle. Upon dilution, number of moles do not change. So when we should know when we use this formula. When we use this formula, whenever you observe volume is added, water is added, solvent is added. Okay, online students. Next, resultant molarity. Dilution principle formula is over M1 V1 is equal to M2 V2. Next, resultant molarity. For each formula, we will do one model question after completion of theory. So prepare mostly on holiday from Ugadi. We will do. Okay. Next, resultant molarity. We are doing second year physical chemistry. Okay, we are doing first year as well as second year physical chemistry. Solution first part only. This is a resultant molarity. You know already, most of you. Tell me M resultant. Anybody? Online students. When we use resultant molarity, first of all, write the formula M1 V1 plus M2 V2 plus M3 V3 and so on by V1 plus V2 plus V3 and so on. M resultant. So dilution principle is used when water is added. M1 V1 is equal to M2 V2. Okay. When we use resultant molarity, Yashvi, Pranayi, you know already. Can you tell me? Yashvi, can you try? Pranay and Yashvi. Yashvi. Okay. You, Yashvi? No idea. This is solution 1. This is solution 2. Solution 1 and solution 2. Solution 1 molarity is M1. Solution 2 molarity is M2. Volume is V1. Volume is V2. Okay. One condition, both should be similar. Similar in the sense, once look at this. Both should be acids or both should be bases or both should be salts, similar natured. When we mix similar natured solutions, we can mix two acids. Take two different molarity volume acids, you can mix. Take two different bases. But you cannot take one acid and one base. If we mix one acid and one base, another formula is there. When we mix two acids, when we mix two bases, or when we mix two salt solutions, then we use this same resultant formula. Remember, okay? That is important condition. When we mix two similar natured solutions, then what happens? We will get one new solution, that is called as resultant solution. So to find the molarity of this resultant solution, we use this formula. M resultant is equal to M1 V1 plus M2 V2 by V1 plus V2. It is temperature dependent or independent term. Molarity. Any idea? Molarity is temperature dependent or independent? Online students? Online students are not responding. Temperature dependent. In molarity, once see all of you, in molarity, volume term is present or not? In any concentration term, we have different concentration terms. Weight percent, weight volume percent, molarity, normality, molality, mole fraction, ppm. In any concentration term, if volume is present, that is temperature dependent. Which of the following is temperature dependent concentration term, temperature independent concentration term? Okay, like that also we'll get questions. This is temperature dependent or not? Temperature dependent concentration term, molarity. Write one note. It is temperature dependent concentration term. Molarity is dependent on temperature or temperature dependent. Temperature dependent concentration term. Units for molarity. What is basic formula of molarity? Number of moles by volume. So mole, liter inverse. Next, second concentration term, normality. Normality, symbol for normality, N. Number of gram equivalents. Number of gram equivalents. In 1 liter solution. Number of gram equivalents in 1 liter solution is called as normality. Today we are going to discuss very important topic that is useful for ionic equilibrium chapter also. Fundamental topic, condition for neutralization, nature of the solution, number of gram equivalents in 1 liter solution. Normality is equal to GN, number of gram equivalents by volume in liter. This is basic formula, first formula. From this you tell me, first of all write GN. What is GN? How to expand this? What is abbreviation for GN, Kirti? GN abbreviation, how to read it? Number of gram equivalents. Number of gram equivalents. Number of gram equivalents. Number of gram equivalents, GEN. Very important. How to find GEN? Look at this, all of you. number of gram equivalent. See, if you have idea about this GEN and formula of GEN, then you can understand ionic equilibrium questions. Okay, GEN is equal, tell me, send N V that side. Number of gram equivalents is equal to N into V. Remember, number of gram equivalents is equal to N into V. Number of moles is equal to M into V. Number of gram equivalents is equal to N into V. Okay, milli equivalents. Milli equivalents. Milli equivalents is equal to normality into volume in ml. Normality into volume in milliliter. This is milli equivalent. Next formula. Did you complete online students equivalent weight numericals? How many of you did equivalent weight numericals? I sent in the PDF, right? Yashvi completed? Ketara, did you finish? Pragnika? Offline students, you. Oh, I will add. గ్రూప్లో ఉన్నావు కదా నువ్వు. నేను క్వశ్చన్స్ పంపాను, చేయండి. చేయలేదు, మళ్ళీ మాట్లాడదాం మనం. ఓకే, క్లాస్ డిస్టర్బ్ అవుతుంది. నెక్స్ట్ సెకండ్ ఫార్ములా. నార్మాలిటీ ఈజ్ ఈక్వల్ టు weight by gram equivalent weight into 1000 by volume in ml. See, yesterday we completed one important topic. What is the topic? Tell me. Yesterday we completed one important topic, equivalent weight topic. How to find equivalent weight of acid? Equivalent weight of acid. Molecular weight by basicity. Okay. Write dilution principle directly. N1V1 is equal to N2V2. Explanation is same. This is called dilution principle, similar to molarity dilution principle. Both are same only. Resultant normality. N resultant is equal to N1V1 plus N2V2 by V1 plus V2. Density and normality. Normality is equal to weight percent into 10 into density by, guess here, gram, molecular weight, gram, molecular weight, gram, equivalent weight. In molarity, molecular weight. In normality, equivalent weight. Gram equivalent weight. You know how to find gram equivalent weight. Vasavi, how to find gram equivalent weight of salt? లాస్ట్ క్లాసే కదా ఉంది, గుర్తు తెచ్చుకోండి ఒకసారి. How to find gram equivalent weight of salt? Molecular weight by charge over cation, charge on the cation. Normality, temperature dependent or independent term? Independent. Dependent. Volume term is present. Write one statement below that. Normality is temperature dependent. Depends on the temperature. See, formulas are similar. If you learn molarity formulas, normality are similar to molarity formulas. First chapter only will go like this, because in first chapter important basics will come. That's why we are going slowly. Second chapter onwards I will increase the speed. I already said this yesterday. Keep adding relation between normality and molarity. Ashrit, can you try? We already completed. Remember again now. Sweta, relation between N and M. Relation between N and M. substance. N factor. Now are you getting idea, Sweta? Acid, base, salt. For acid, N factor nothing but basicity. For base, N factor nothing but acidity. For salt, N factor nothing but charge over cation or anion or valency of the ion. Charge over cation or anion. Now anybody can you say the relation between normality and molarity? Normality is equal to N factor into molarity. Remember the relation, read the concepts. Okay, we will do numericals. If we know molarity, we can find normality. What is basicity of H3PO2? Priyanka? H3PO2 basicity. H3PO3, okay. H3PO3 basicity. Number. Basicity means number. 2. Number of oxygens minus 1. 3 minus 1, 2. Once I am revising important N factors. For these, N factor is different, okay. Number of oxygens minus 1. Next. See, under normality concept, we will discuss neutralization condition. Very important. Actually, see, one question is coming. Sometimes that is considered in stoichiometry. Sometimes that is considered in ionic equilibrium. Okay, anywhere we can finish here or in the ionic also, but let us finish here only. Keep heading. Condition of neutralization. Condition of neutralization. Why am I explaining now only? Because recently we completed equivalent weight, right? That's why it is better to discuss now only. Condition of neutralization. Condition of neutralization. See, when we mix one acid and one base, that is called a neutralization. Formation of salt and water is called as neutralization. Okay. One condition is there to do neutralization. Okay, then only we will add acid and base. What is that condition? See, the condition of neutralization, gram equivalents of acid is equal to, first condition, gram equivalents of base. See how this condition is useful for us. How this is useful in the numerical part. I'll tell you. Gn of acid is equal to Gn of base. So remember, what is the condition of neutralization? Gn of acid is equal to Gn of base. We know what is Gn. At the beginning I given. Once look at this. Gn stands for here. Gn is equal to N into V. Normality into volume in liters. So write in place of Gn, N into V. Actually volume should be in liter, but we can take in ml. Why? Because if you wanted to convert into ml, what we have to do here? In 2000. Here also in 2000. Both will cancel now. So you can take directly in ml. When data is given in liter, you can take directly in ml. Why? Because here you will convert, here also you will convert. Both side 1000 will be cancelled, right? So N into V of acid is equal to N into V of base. This is the condition of neutralization, right? How questions will come on this? See, the volume of 0.1 normal HCl required to neutralize 0.1 normal 10 ml NaOH. How much volume of some 0.1 normal acid is required to neutralize some 0.1 normal 20 ml NaOH, like that. Based on this condition, what will calculate? Amount of or volume of acid required to neutralize a base, or volume of base required to neutralize an acid, or normality of acid required to neutralize base, like vice versa, based on the given condition. See, first formula is used when both acid data, base data is given in volumes. But you tell me, when one data is in volume, means acid data, and base data is in weights, then how to find? Sometimes you will get like this also. What is the weight of sodium carbonate required to neutralize some 0.1 normal 20 ml H2SO4? Weight. One is weight, one is volume. Then how to find? Based on the given data, we can convert this GEN into weights. Once look at this GEN. Once look at this. We didn't write this basic formula GEN. Here. This is nothing but GEN only. This is GEN only. What is GEN? Since GEN is equal to weight by gram equivalent weight, like number of moles. What is number of moles formula? Weight by gram molecular weight. Number of moles weight by gram molecular weight. Number of gram equivalents weight by gram equivalent weight. So I am converting, sorry, I can convert this. Here also we can write, but mostly base is given in terms of weights. Okay. Now you tell me, in place of GN, what we can write in terms of weights? GN is equal to weight by gram equivalent weight of base. This is common. This volume term is common, N into V. But here one important point. When ml, volume is given in ml, we use this. Mostly we use this only, remember this. When weight is given, volume will be given in ml, in most of the cases. When we use third formula, tell me, when we use third formula, when base data given in terms of weight. When base data given in terms of weight. This is condition of neutralization. Read all the formulas and be ready. Okay. Next, molarity is over, normality is over. Okay, molality. Keep heading molality. Next concentration term, molality. Molality, L. See, number of moles of solute. This is 1 mole, this is 1 mole, this is 1 mole. 1 kg of solvent. Number of moles of solute present in 1 kg of solvent is called as molality. Here 3 moles are present in 1 kg solvent. So molality is 3. How many moles are present in 1 kg solvent? 3. So molality is 3. Number of moles of solute in 1 kg of solvent. Definition is important. Write definition. Number of moles of solute in 1 kg of solvent is called as molality, represented by small m. Last year, recently, one question came based on the relation between molality and molarity in the NEET. First, write basic formula for molality. Molality is equal to number of moles by weight of solvent. Weight of solvent in kilograms. Basic formula. If we want to take weight in grams, then molality is equal to number of moles by weight of solvent in grams into 1000. 1000 will come in the numerator. In place of n, again what we can write? In place of n, weight by gram, n number of moles. In place of n, In place of n, weight by gram molecular weight into 1000 by weight of solvent in grams. Okay. Now you tell me. Anybody? Online students. Molality is temperature dependent or independent on the temperature? Online students. Independent, because there is no volume term. There is no volume term, and very important theoretical point. The best used concentration term is molality, because there is no volume term. So there is no fluctuations in the volume, fluctuations in the molality. Best used concentration term. Which of the following is the best used concentration term? Molality. Write one note. M is temperature independent. Do not depends on the temperature, because there is no volume term. And M is best used concentration term among molarity, normality, mole fraction. Best used concentration term. Right, very important. Relation between small m and capital M. Molarity and molality. Second years and long term students. Any idea? Yashvi, are you there in the class? Yashvi, Pragnika? Molality. Yashashvi, tell me. Ashvi, relation between molality and molarity. Good. See, molality is equal to small m. Molarity into 1000 by density into 1000 minus molarity into gram molecular weight. See, gram molecular weight is always considered for solute only throughout concentration terms numericals. If you want to write in the bracket solute. Which gram molecular weight we take? Solute gram molecular weight. Generally gram molecular weight is for solute only. In NEET question came on this recent years only, 2 years, 3 years back only. Okay. Important relation. M is molarity, D is density. Gram molecular weight. Next, mole fraction. Keep adding mole fraction. Mole fraction. Sir, కూర్చోండి. టెస్ట్ రాస్తావా రేపు? మరి రాస్తావా టెస్ట్ ఇండక్టివ్ మీద? Without having idea about mole fraction, you cannot do numericals on the Raoult's law. 100% probability question in the solution is Raoult's law. In Raoult's law, mole fraction basic is useful. Let us start mole fraction. What is the name for this symbol? Chi. Generally we call it as X, but chi. Same story. 3 balls and 4 bats. All these are bats. Number of balls, how many? 3. Number of bats, how many? 4. Total count? 7. Now you tell me, here I am giving one ratio. What is the meaning, or that ratio represent what? 3 by 7. This represents Ratio between number of moles of balls and total count. And this one, number of bats by total count. So mole fraction nothing but it is the ratio between number of moles of one component and total moles of all the components. Ratio between number of moles of one component and total moles of all the components. Number of moles of one component and total components. This is important, that's why we cannot ignore it. See, all of you consider. Now I am considering balls as A. A is one component. In place of B, I am considering bats. I am considering B. A is one solvent. B is another solvent. Okay. In place of balls and bat, imagine two different solvents. A and B are solvents. Okay. Number of moles of A is how much?
A by A.
3. But consider it as a N. Consider a binary solution. This is a binary solution, two component solution. Consider a binary. This is not derivation, just introduction. What is a binary solution? Binary means two component solution, right? Na represent number of moles of component A or solvent A. Na is equal to number of moles of solvent A or component A. A is solvent or component. Nb represent number of moles of component B or solvent B. B is component or solvent. In place of balls and bats, imagine two solvents, very simple. Binary solution or two component solution. Right, what are total moles, you tell me?
Na by
Here this Na nothing but this number 3, 4 we took in the last example. Total moles. Total moles is equal to Na plus Nb, sum of all the moles. Na plus Nb. Right. Mole fraction of A is equal to, what is the definition? The number of moles of one particular component by Na plus Nb. Mole fraction of B is equal to Nb by Na plus Nb. We know what is Na, number of moles of A. How to find number of moles of A? Weight by gram molecular weight. Okay. In any solution, the sum of the mole fractions of all the components is equal to unity. Xa plus Xb plus Xc and so on is equal to 1. In Rolle's law, we use this. Xa plus Xb is equal to 1. Mole fraction do not contain units. This is a number, yes or no? For mole fraction, no units are present. In numerator, number is there. Denominator also number is there. Number only. No units. Okay. This is about concentration. ppm I will give you tomorrow. Okay. When is holiday for you? Tomorrow or day after tomorrow? When is your festival? 21st. Holiday we will cover maximum. Okay. Okay. See you. Thank you. You can leave, online students.